A very good morning. This is Dr. B. Ramchandra, Assistant Professor, Department of Chemistry, Humanities and Basic Sciences, AITS, Tirupati. So today we are discussing fuels for IC engine. So what is meant by IC engine? So first of all, we know the IC engines. So SA engines, IC engines. There are two types of engines are there. We know what is IC engines. The full form of IC engines is internal combustion engines. So this engine is a heat engine in which the combustion of a fuel occurs with an oxidizer. So usually air. So in a combustion chamber, that is an internal part of the working fluid flow circuit. So that is known as IC engines. So what is the role of IC engines in motor vehicles? The internal combustion engine, which converts the chemical energy of a fuel into the mechanical energy by combustion of the fuel or burning of the fuel. While the fuel is continuously burned, the chemical energy should convert it into the mechanical energy. So that is the role of IC engines in motor vehicles. Next we go for classification of IC engines. Classification of IC engines. So here fuels, some of the fuels are suitable for the IC engines because of these fuels are partially converts chemical energy into the mechanical energy while combustion. So for example, we see the hydrocarbons, that means liquid fuels, alcohols, so that means methanol, ethanol, LPG, that means propane and butane, natural gas, methane, and hydrogen. So these are the some of the fuels which are useful for the IC engines because they are easily converts chemical energy into the mechanical energy while burning. So that's why these are the fuels are most important for IC engines. So next we go for liquid hydrocarbons. Liquid hydrocarbons. So these hydrocarbons by having the general formula CN HN. Fuels are mixtures of hydrocarbons having covalent bond between the carbon and carbon atom. So that means carbon and hydrogen atom. So these liquid hydrocarbons, they forms a straight line chain. So in that straight line chain between the carbon atom and carbon atom, covalent bonds are present. Between the carbon and hydrogen atom, there will be formation of a covalent bond. So during the combustion, these covalent bonds are broken and new bonds are formed with oxygen atoms with the release of chemical energy. While burning the fuel, which releases chemical energy, so that chemical energy should convert it into as a mechanical energy, that is the IC engine they are doing. So while combustion of liquid hydrocarbons, the main products of carbon dioxide and water vapor, that is, these are the byproducts of carbon dioxide and water vapor. So next we go for alkanes or saturated hydrocarbons. Saturated hydrocarbons may having various compositions, depends upon the various stages they are available, saturated hydrocarbons. So because they're having the variation of composition in the hydrocarbons, depends upon the various stages. So firstly we see the saturated hydrocarbon in the form of gas. They may having the saturated hydrocarbon 1 to 4 composition, and these saturated hydrocarbons available in the form of liquid, they may having 5 to 15 hydrocarbon compositions. So in the form of solid, they are having greater than 16 as a hydrocarbons. So these saturated hydrocarbons shorter in the chains, highly tendency for auto ignitions. So auto ignition. So what is meant by ignition? So ignition means the electrical system that starts the engine of a car. This is a electrical system that starts the engine of a car. So that is the auto ignition. So they are having high hydrogen atoms and low density. So alkanes with straight chain compounds are called normal paraffins. Already discussed. So these hydrocarbons are form along straight line chains. So these normally formation of chains are called as a paraffins. So what is meant by paraffin? So paraffin is a type of oil is burned to produce heat or light. It is made from the coal or petroleum. So paraffin is a oil. So these oil burned to produce heat or light or energy. So some of the branched chains are called as a isoparaffins. So that means the branched chains of isomers of a straight line chain is the isomers of alkene. Isomers of alkene is known as isoparaffins. Then we go for naphthalenes or cycloparaffins. So saturated cyclic hydrocarbons, are known as cycloparaffins. So next, these cycloparaffins may having the low tendency. These are used for both SI engines and IC engines, compression engines. So these wheels are having low heat content and high density. So they having 735 to 785 kgs per meter cubed as a density. So these are the saturated hydrocarbons we are using for IC engines. So next we go for saturated hydrocarbons, we discuss. Then we go for unsaturated hydrocarbons. They having the chemical formula, general formula. So general chemical formula CnH2n. So these unsaturated hydrocarbons, they form as a straight or branched chain compound with one or more double bonds. So just like heterocyclic compounds, unsaturated hydrocarbons. So these compounds are easily oxidized because of they having the low oxidation density, low oxidation, a very low oxidation stability. So that's why they easily go oxidized. So these are used for SI engines. They form by the cracking a large molecules, low heat content and density in the range of 622 to 23 kg per meter cube. Then we go for aromatic compounds. These aromatic compounds are used for SI engines. So SI engines means a spark ignition engine. A spark ignition engines are known as SI engines. To enhance the resistance to knock, not suitable for IC engines or CA engines, compression engines, internal engines or IC engines. So which is only useful for the SI engines as aromatic compounds. So then we go for alcohols. So alcohols may having the OH functional groups in the place of hydrogen atom in alkanes. So this specific heat of alcohols is low than the gasoline. So the alcohols having the specific heat is lower than the specific heat having the gasoline. So there is a mixture of fuels having alcohols are comparable with the gasoline. Some of the alcohols groups like dihydric and dihydric alcohols are not used for the IC engines, internal combustion engines. So methanol and ethanol can be used in low concentration in gasoline to increase the octane number of the mixture. So here we using alcohols for IC engines, useful alcohols for IC engines. Then we go for gaseous fuels. So they're having the low tendency to knock and low emission. So LPG is the best gas for IC engines. So these LPG having the composition of propane and butane, which provides a good mixtures with air and results in the complete combustion. So low sulfur content and a high octane number. LPG having lower density and heat content when comparing to the gasoline. So density is low, heat is low when comparing to the gasoline. So next we go for diesel engines, diesel fuels. So it is one of the important fuel which is derived from the petroleum by the fractional distillation process. During the fractional distillation at 250 to 320 degrees Celsius temperature or 250 to 320 degrees Celsius boiling point, we get the diesel. So diesel may having the C15 to C18 as a carbon composition. So here the diesel may having the density 8.6 to 0.59 kg per meter cube, and they having the calorific value 11,000 kilocalorie per kg. So that is the diesels we derived from the petroleum by the fractional distillation. So during conversion of a fuel in a diesel engine is not instantaneous, and they can make some gaps between the engines of fuel injects. When we inject the fuel into the engines, and its ignition is called ignition delay. So why we using diesel to the IC engines? They make a delay due to the time taken for the vaporization. So long ignition delay leads to the accumulation of more vapors in the engine, and when ignited and explodes, which is combined effect increase the temperature and pressure. It rises and temperature and pressure. So this reversible for the diesel knock. So these are the responsible for knock. Why we getting knock in the motor vehicles while using the diesel? So only one reason: a long ignition delay to accumulation of more vapors in the engine, and when ignited an explosion. So which is responsible for the knock in the diesel engines? The because of effect of high temperature and pressure, they produce knock. So let's see the, so what is meant by knocking? So knocking is a sharp metallic sound produced in the internal combustion engine. So knocking is a sharp metallic sound produced in the internal combustion engine. Knocking is caused by the low octane number of gasoline. Low octane number of gasoline. So anti-knocking agent is a gasoline additive used to reduce engine knocking and increase the fuel octane rating by raising the temperature and pressure at which auto ignition occurs. So here we see one thing, what is meant by octane number. So what is meant by Stirred number? So first of all, we know the what is octane number or octane rating or octane ranking. So octane number or octane ranking, so which is the measure of fuel's ability to resist the knocking during the combustion. So that is the octane number. So what is octane number? It is a measurable of a fuel's ability to resist knocking during the combustion. That means to measure the ability, that means efficiency of fuel to resist the knocking during the combustion. So that is known as octane number. So here we see the octane number is defined as the percentage of isooctane present in a mixture of isooctane and N-heptane. N-heptane produce maximum knocking and its octane number 0. So knocking means, so while burning the fuel, they give some metallic sounds. So that is the knocking. So we are using the fuel. That fuel may having the N-heptane in the fuel which produce maximum knocking and its octane number is 0. Whereas isooctane produce minimum knocking and the octane number is 100. So these are the chemical structures of N-heptane. and isooctane. So while which is N-heptane existed in the field which produced knocking, so they having the 0 octane number. So here isooctane which is present in the field which resists the knock. So there is difference between, that's why they having the octane number as 100. So next let's we see the what is cetane number. So cetane number means cetane number or cetane ranking or cetane rating, whatever it may be. So it is a measurement of the quality. It is the measurement of the quality or performance of diesel fuel. Okay, to check the performance of diesel fuel. So higher the cetane number, better the fuel burn within the engine of a vehicle. So otherwise, they minimizes, which causes delay. Already we discussed. We are using here diesel. So the diesel having the causes a delay. Why they causes delay means the performance of the diesel fuel is lower. The combustion should take a delay. So this is responsible for diesel knock by using the by using the diesel knock, which take a delay, which produce knock because of delay of combustion of fuel in engines. So let's see the cetane number. The knocking characteristics of a diesel oil are expressed in terms of cetane number. So that's the characteristics of a diesel. That's we says it is a measurement of to check the quality or performance of the diesel. So that is the characteristics of a diesel is a cetane number. So let's see what happened. So the percentage of cetane number in a mixture of N-cetane and alpha methyl naphthalene giving the same performance that of the diesel oil under the tests. It may be increased by addition of ethyl nitrate or amyl nitrate. So we see here alpha methyl naphthalene having the cetane number 0 because the performance of diesel which is having alpha methyl naphthalene which make a delay. So here the N-hexadecane we are using the cetane number is 100 because which is existed in a fuel as a diesel, they may having the a good quality, a good performance of diesel which is having the higher cetane number which burns within the engine of your vehicle. So that's why the N-hexadecane may having the cetane number 100. So we are discussing today fuels for IC engine. So thanking you.